speaker is Dr. Sharath Butkonda. He is an IIT Kharagpur 1997 alumni, atmospheric scientist, and founder of Urban Emissions India. His main research interest is air quality analysis and finding ways to bridge the gap between science and policy. He was a member of India's AQA Formulation Committee 2014, Special Advisor to the Ministry of Health and Family Welfare, Air Pollution and Health Steering Committee 2015, a member WHO's Air Quality Guidelines Development Group 2016 to 2020. He received his PhD from University of Iowa 2002 and currently serves as an adjunct faculty of IIT Delhi's TRIP Center. He is a recipient of AGU's International Award in the year 2022, which is given annually in recognition of furthering the earth and space sciences for the benefit of society in developing nations. He is the second Indian to receive this particular award and the first in this particular domain. So we welcome you, sir, and he'll be discussing on the data resources for vehicular emissions analysis in India. So we welcome you.
Thank you. Thank you. Brajesh, can you share your screen, please?
Yeah, sure.
Thanks.
Yeah, can you see that?
Yeah, I can see that. Thank you. Thank you. Thank you. I mean, a lot of number crunching has already been done. So I'm kind of jumping in the middle of this work. So what we do at Urban Emissions is a lot of number crunching, especially on emission side and taking it to pollution, trying to understand source contributions that will help in policy dialogue at the city level. And also, we also push some of this information to the ministries to have sectoral level dialogues as well. Next slide, please. A lot of the work that I'm showing you today was done with collaboration at the TRIP Center in IIT Delhi, Dr. Geetam Tiwari, Dr. Rahul Goyal, and late Dr. Dinesh Mohan. And when we've been working with them for almost 15 years in this regard, and there's a lot of overlap in some of the work that I'm presenting today. Next slide, please. So when we talk about emissions analysis, there's I mean, it's a very data intensive work. It's already been talked about in the previous presentations. And coming from an air quality perspective, it actually adds a few more dimensions to it. Not only trying to understand how much is the pollution, which is the volume of it, but we also need to understand where is the pollution in terms of where are the hotspots. In the transport sector, it's very obvious everything will be on the roads, but even when we consider roads, where is the freight vehicles intensity, where is the residential vehicles moving, where are these origin destination matrices being built and used for some of this spatial aggregation of the emissions. So we need there's another dimension that comes into the play. And if we do everything right, a lot of work can be done in terms of understanding your temporal profiles, spatial profiles, intensity profiles, and then take that to the next stage of dialogue. Next slide, please. For the transportation sector, I would like to always go with the fundamental equation. When we talk about emissions, it's basically your number of vehicles, kilometers traveled, and emission factor. So these are the three main buckets that we really need information for in taking it forward. And it also helps in putting another layer to the same three categories here, like supply side, especially when we're talking about policies. So supply side in the sense, can we reduce the number of vehicles on the road, whether by not selling the vehicles, because we have seen some of those policies happening in Singapore where they tax too much to reduce the number of sales. If that happens in China also, they limit the number of registrations or the auction of the registrations, then the number of the sales comes down. Or if people have the vehicles, but we don't want them to use it. So how do we do that? So supply side, are there any policies that we can play with? The demand side is the vehicle kilometers traveled. All that mobility demand is happening. That's happening on the roads. So can we reduce the vehicle kilometers traveled in different vehicle categories, whether it's cars or motorcycles? Can we move them to metro? Can we move them to bus? Or can we move them to NMT? So you have a different set of policies that you can evaluate over there. And then you have the technology itself, which is the emission factor, where when we already have a lot of discussion on the Bharat standards. Over the years, we have moved from nothing to Bharat 1 to now Bharat 6. So technology has improved in the vehicles and in the fuel that's being supplied in the cities. So there is some improvement happening. There is also EVs being pushed now, and there is also the mix of fuel with bioethanol and biodiesel being pushed now. So that is coming from the emission factor perspective. So if we start looking at, this is my equation and these are my buckets, what kind of data is available to feed these policy discussions? So my presentation is primarily from that perspective. I want to show you what kind of information is already available in the public domain, which needs to be massaged to use it for some of these dialogues, and what kind of information we are collecting via surveys and clearing all the noise in some of the data. Next slide, please. So there are 6 main categories. Again, this is also mentioned in some of the presentations earlier, where we need to really focus on. The 3 main buckets that we saw earlier, the number of vehicles, vehicle kilometers traveled, and emission factors, that's more a tier 1 equation. The tier 2 will be trying to understand more nuances within those 3 categories. So I'll go through each of these in a bit more detail. Next slide, please. Level 1 of this work, which was done in 2013, 2014, it was published a couple of times, and also is part of the NTDPC document before Niti Aayog, the Planning Commission phase, and where we actually did a lot of surveys and used that to understand the projections in vehicle numbers, projections in vehicle usage, and then what could be the trajectory in the technology that will help us in building some of these scenarios. So some of that information is already included in those reports. So if you have any questions, want to access that, please let us know, and we'll be able to furnish some of those details as well. Next slide, please. So I will quickly jump into each of these categories. The first thing is the vehicle type. Now, what kind of vehicles are there registered, also on the road? So this is something that we really need to differentiate. So a lot of work that we see sometimes comes from a registered vehicles perspective, but we need to start understanding the difference between registered vehicles and the in-use vehicles. And the next slide, please. So if we purely go by the number of vehicles registered in the country, we see a certain trend that we are in the number of vehicles all the way. So there's a lot of vehicles that are there. Almost every sector, the number of vehicles have increased. That's a given thing. And going forward, if we don't put in right policies in place, all these lines are definitely going to increase more and more. So one of the lines that we really see has been flat pretty much over the years is the bus line. The number of buses that we're introducing into the cities to catch the demand, the required demand, mobility demand, it's pretty constant. The reason why it's pretty constant is because we only replace the vehicles. We are not really increasing the fleet. Now, if you take Delhi, for example, in 1997, 1998, when the conversion of diesel to CNG movement was happening, the city had about 2,000 vehicles. Then the Minister of Environment and Forest, they did come up with a white paper and said that, okay, to meet Delhi's demand, we need 15,000 vehicles, 15,000 buses in the city. When it's a projection that they made in 1998, okay, and the projection was for 2000-2001. Now in 2022, the total number of buses running in the city is 4,000. No, that's a DTC, Delhi Transport Corporation's capacity. And even now, a new action plan proposed for Delhi says, oh, we need 15,000 buses. So every time there was need for buses, it was always has been for replacement of the older fleet, but never in increasing the fleet. So when we talk about number of vehicles, how do we reduce the demand for personal vehicles? Now, this yellow line has to move up. Okay, so this is something that we have to keep pushing. So the data exists on the total number of vehicles, and this is what we understand so far in the registered vehicles registered vehicles information from the MORTH, where they publish it through annual reports. The next slide, please. I mean, we did some projections on this going forward, what will be the demand of this, but keep in mind that the official numbers that we get from MORTH annual reports are always 2 or 3 years backlog. And within that, if you start digging a little deeper into how each of the states report these numbers, there are a lot of holes. And this is where we end up spending a lot more time in filling these gaps, so that we have a lot more cleaner understanding of how the vehicle fleet is increasing. So, but those gaps now are slowly becoming a bit less of a tedious work because of the Vahan website, which was released about a couple of years ago. It's a lot more populated now over the last few months. But the only thing is that the data is not immediately accessible. You need a lot of permissions to access that. But if you have a good IT team, you can pull some of this information both at the state level and also at an RTO level, and start looking at what the trends are at a very micro scale as well, not just at the India scale, but also at a micro scale. We can give you access to some of the stuff that we have already pulled and put together. The next slide, please. So keep in mind, the graph that you see is registered vehicles. So in the sense, if a vehicle is registered, we register that vehicle for 15 years. If that vehicle has gone out of the system, we really don't remove that number from the RTO registry. And if somebody sells the vehicle and gets re-registered, there will be a new number, but the old number is always still in the system. So we've actually done some of these checks. So there is any given day, what we feel is that about 55% of the vehicles are the only, they are the only in-use vehicles. On any given day, we can get rid of 45% of the vehicles. But over age, that survival function changes. So this is where some of the extra work was done in understanding how vehicles survive in different cities. Next slide, please. So the vehicle usage. So this is where the survival function comes in, and then how the same surveys can also be used to understand how is the fuel intake changing, how is the fuel intake changing by age. The next slide, please. So this is a quick survey. We're already published in a couple of papers, but we can give you the access to the data directly. Next slide, please. So this is a quick survey that was first done at IIT Delhi in a couple of cities, starting with Delhi. And then most recently, we done this work in 3 cities in Bihar, in Patna, Gaya, and Muzaffarpur. And mainly to understand what is the in-use vehicle fraction in the city, and does the survival function change from city to city, like from tier 1 to tier 2 to tier 3 cities? Is there a big difference? And there is a big difference. I have some examples in the following slides. And we do all these surveys at the petrol stations. So the underlying assumption being that only the vehicles which are in use, they're coming to the petrol station, and we make sure that the sample size is large enough that we create a age function for vehicle usage through the odometer reading and the fuel intensity via one of the questions that we ask is, what kind of mileage do you get for these vehicles? So we use that to build a age dependent fuel intensity for the vehicles. The next slide, please. This is a quick summary for Patna. We collected 10,000 plus samples. We had 19 students from different universities who participated in that. Over 10 days at 10 different stations, we were able to collect a good amount of sample for the passenger vehicles, for cars, jeeps, scooters, and autos. And it was a really good learning from a couple of different perspectives. One is the data itself and build all these graphs, but also in the operations as well. A quick story around that. In 2010, when we did the surveys, at that time everything was on paper, and other cities also we did on paper. It was very easy. So in the new age of apps and stuff, in 2018, when we were doing in Patna, we actually had an app where we asked students to do the survey and immediately enter it, so that in the evening we can start doing the some of the math. But surprisingly, people at the petrol stations refused to give information to the phones, directly to the phones. They were hesitant, like, what are you entering in the phone? I don't want it. So within an hour, we have to move back to the paper, and no, everybody was okay with you writing down the information, but they were not happy with us entering the data directly into the phone. So it was a good learning. I don't know, it was mainly in Bihar, but I mean, we had mixed reactions in Indore and in Vishakhapatnam, but it was a good learning. But it was a good interaction. People, there was almost 95% of the people responded and gave us, we agreed to answer the question that we were asking them. The next slide, please. So in Bihar, in Patna, it was really interesting to understand what is the average age of the vehicles. For example, for cars, it came up to 6 years. Like fleet average was about 6 years. Same survey that was done in Delhi, average age was 4.5 years. So which means that the rotation rate of vehicles in a tier 1 city is much higher. Under between 4 to 5 years, people are changing their vehicles. And when it came to tier 2 cities like Patna, it was 6 years. And in a tier 3 city like Gaya and Muzaffarpur, which are not far from Patna, they are literally 30 kilometers south. There, the average age was about 0.5 higher, like 6.5 years. So it was interesting to see the change in the fleet averages, and also the age mix itself. Here you can see we put a mark at 10 years. How many vehicles that are coming to the petrol station are older than 10 years? So it was really interesting to see that. So the cars, about 16% of these vehicles were older than 10 years. But in the same survey in Delhi, it was 5%. So which means that one of the things that we wanted to showcase with this graph is, if a policy is put in place where we say that, okay, we are going to ban 100% all the vehicles under 10 years. Now, is that going to really have an impact? So if you go by the registered number of vehicles, that share is very high. But in use, that share is not so high. So when we have to be realistic in pushing policies which will, on paper they look very nice, but on the ground, looking through these numbers, they may not be as beneficial going forward. So it was a really good learning of that as well from the surveys. Next slide, please. So the next one is the maintenance. So this is again a program which is there in India to understand whether vehicles are being maintained properly or not, but the program itself is heavily flawed. Next slide, please. So this is the pollution under check program. The biggest flaw is that it's an idling test, because it's not on a chassis dynamometer the way it's done in US and in EU. It's idling test. You take the vehicle, if the vehicle is running for the last 10 to 15 minutes, you will have a good test, no problems. But only thing is, they don't measure PM 2.5, they don't measure NOx, no measurement of SO2, which are the primary pollutants for air quality. And they definitely are not measuring CO2, which is something that you guys are focusing on. CO, it's an index number, which pretty much every vehicle which is running for 10 to 15 minutes hot, it will definitely pass. And the VOC is also a very old standard, also a ratio, which will, again, most of the vehicles pass. So irrespective of your age and the condition of the vehicle, most of the time you will get a PUC certificate. So this is something that has been flawed, but we still ended up using some of this data, not from the emissions perspective, but to understand the degeneration of the engine. So that CO index value has been very useful in that perspective. So we noticed that with the age, that CO index value there is some change that can be used to understand the deterioration rate of the engines. So this is something that we took it out and tried to understand. I mean, if I have an emission factor rate for a certain fleet, and I can apply a deterioration rate based on the age and do some of the corrections on the fleets and take that forward from there. So we are trying to redo some of these works for the big cities where the PUC data is now available, not in the public domain, but if you have some connections with the ministry, MOPNG, they are providing some of this information. So we are redoing some of this work at IIT Delhi going forward. The next slide, please. Yeah, so the emission factors, I put a big star there, mainly because a lot of the emission factors work that's done is on a very small sample in India, and a lot of work literally is happening on a beg, borrow, and steal format. Ideally speaking, next slide, please. So we would like to have a lot more tests done in a proper way, so that we don't see some of these scandals like Volkswagen scandal. I think there was ICCT is trying to do very similar tests in India as well on some of the vehicles to understand if something similar is happening in India also. Let's see what they come up with. The next slide, please. So ideally speaking, we would like to have these emission factors done on an in-use basis. This is a very good example that we found from JRC, where they have a full tutorial on how to put together a emission factor test kit for in use. Now the vehicle will be on the road, so you don't have to limit yourself to a pre-established driving cycle that you can run for 900 seconds in a lab, but have the vehicle run on the road, so you can test different types of roads, highways, small roads, arterial roads, feeder roads, and try to come up with a more road specific or in use fleet specific emission factor. But I mean, this is a optimistic thinking. Hopefully these works will happen in the future. The next. So the last one is the road network. This is where the spatial element of the whole exercise comes in. Next slide, please. So what we try to do is to understand where are the vehicles moving. So this is one source that we access, which is a paid source. It's not a public source. So Google Maps have this distance API, where you can actually create an origin and destination matrix and get the data for how the vehicle speeds are at different hours. So this is not a real-time thing. We did this for about 2 weeks for different cities, and we created different sets of origin destination matrix. If all the vehicles were just moving around in the urban centers, that's the Delhi side, the top graph. If all the vehicles were just moving around in the urban grids only, what kind of roads are being accessed? The next one on the right hand side, the black lines, is basically all the vehicles are moving from the urban grids to the outer cells outside the Delhi area. So what kind of roads do they access if that's happening? And the third third graph is basically all the vehicles coming in from outside to a hub, to a railway station, or to an airport. Then what kind of roads are they accessing? So the reason why we try to do this is two-phase. One, to understand the roads that are in use. Because if we access a GIS file for roads from either OpenStreetMaps or directly from the city boards, they'll give you all the roads. So, but we wanted to understand, like, what are the in-use roads where that can be used for spatial desegregation of the overall emissions that we're calculating. So that will help us in properly assigning the emissions to roads based on the intensity of use. So it was really interesting to see. So there was at least a 20-30% discrepancy, I shouldn't say discrepancy, but a shift in the emission intensity distribution in the grids. And that really helped us going forward in some of the chemical transport modeling work. The next slide, please. And the distance API also has a small component in it. It gives you the speed information also. And that we can use, because we were doing it for 2 weeks, we were able to do a weekly profile and diurnal profile and things like that. And this is something that we used for our chemical transport modeling for varying some of the emission intensities. So for example, if a grid shows up as red, where the vehicle speeds are basically in that grid are under 10 kilometers an hour, which means a lot of congestion, means your engine is not running at a full efficiency level, then you will have more incomplete combustion for more CO and more VOC emissions that will be there. So we were able to modulate that. That actually gave us a little kick in the photochemical schemes that are there in the chemical transport modeling. So we were able to play with some of those. And also in the dust emission modulation. So if the vehicles are in a congestion mode, the vehicle speeds are not so much, then you can't have dust resuspension happening in those grids. So we were able to cut down on a hour by hour, grid by grid basis, some of the dust emissions also. So there are a lot of learning that can be done in products like these also, but its only drawback is it's a paid service. And Google has actually increased the price about 10 times in the last year, and it's become even more expensive to grab. But we have some understanding of these numbers. Next slide, please. So we've done this for about 30 cities in India. We were happy to share some of these databases that we have pulled and cleaned and ready to use for any of the other analysis that you have interest in. The next slide, please. So overall, I mean, there is some data available. We're always in need for more data, and there are survey methods that are in place that we can use to extend that analysis. And you are also doing some of these surveys and putting together databases. So if there is some overlap, we'll be definitely interested in trying to do a give and take on some of this analysis. Next slide, please. And a lot of these databases that we have already archived, and it's also available on our website, right from the registration number of the registration numbers databases from MORTH and some of the databases that we have put together in the fleet average emission factors and for different cities. And for at least currently about 50 cities work is already online, both in terms of total emissions intensity and on that impact on pollution and health impacts. Only thing is that we focus primarily on air quality, but everything is the same. The equation is the same, the fuel and all the information exists that can be easily extended to CO2 as well. And if any of this information is useful for you, happy to pass it on. Yeah, thank you.
Thank you very much, sir, for your valuable insights on database development for the Indian scenario, as well as this is one of the key important aspects for life cycle assessment. So hopefully we'll be seeing more amount of database developments, which will help us in developing the mitigation measures as well as policies for the Indian scenario.